Welcome to our second video lecture for week 8, chapter 6, discounted cash flow evaluation. As we can see in this chapter, we are continuing the topic of time value of money from the last chapter, chapter 5. We're going to be looking at multiple cash flows, future and present values, multiple equal cash flows, which are annuities and perpetuities. We're going to look at comparing rates and the effect of compounding, briefly look at loan types and some loan amortization. We're not going to get into those really in detail. The first three will be our primary focus for this particular chapter. So, multiple cash flows, future values. In the previous chapter, we used a single cash flow and instances of single cash flows and moved them forward and backward in time. You remember our timelines, present value, compounding yields future value, and future value discounting yields present value. Remember this was our basic relationship using the fundamental equation of finance. Now we're going to look at multiple cash flows. It gets a little more complex. What if we have more than one cash flow? There's really the only difference is that the cash flows are a series of single payments. That's it. They're identical. Instead of one payment, you have multiple payments. They're all single payments. So let's take a look at an example. Suppose you have $1,000 now in a savings account. It's earning 6%. You want to add $500 1 year from now and $700 2 years from now. Then what do you look at for the future value? How much will you have after 2 years from now in your savings account after you make your $700 deposit? So we simply look at each payment separately and move them through time as we did in the earlier chapter. The future value of 1,000 is 1124. Future value of 500 is 530. And then we just add them all up because the 700 doesn't have any interest added to it. And they're all adjusted to be year 3 value. So at the end of year 3, we have $2,354. Another way to do it is to do it year by year. So at the end of 1 year, we have $1,560, and then compound that into 2 years. At 1 year, $1,654. And we get $2,354. Could we do this problem another way? We could, and this is how we just did it. We brought them forward 1 year at a time and add them up in each year. Let's add another twist to the problem. What would be the value at year 5 if we made no further deposits into our savings account? So we see on our timeline, year 1 is 1,000 deposit. Year 0 today is 1,000. Year 1 is 500, and year 2 is 700. So we do this a couple of different ways. The first is to bring the year 2 figure we previously produced to year 5. We get 2803. Second way we could do this is to bring each of the 3 original dollars to year 5 and add them all up. And we can get 2803 as our final result. So to compute the present value of multiple cash flows, we again just bring the payments into the present value 1 year at a time. It's the same thing, again, it's discounting versus compounding. So let's consider receiving the following cash flows. Year 1 is 200, year 2, 400, year 3, 600, and year 4, 800. If the discount rate is 12%, what would this cash flow be worth today? Again, the present value. So So here's our timeline. We're going to discount back to we're going to take each year to the present one at a time. We add them up, we get 1432.93. Here's another example. You're considering an investment that will pay you $1,000 in 1 year, 2,000 in 2 years, and 3,000 in 3 years. If you want to earn 10% on your money, how much would you be willing to pay? So what we're looking at then is 3 separate present values discounted at the rate of 10%. Total present value is 4815.93. When we look at a slightly different situation, we see that in many instances financial instruments pay equal cash flows. These are known as annuities and perpetuities. An annuity is a finite series of equal payments that occur at regular intervals. In other words, it's a set of payments of X value for Y periods. If the first payment occurs at the end of the period, it's called an ordinary annuity. If the first payment occurs at the beginning of the period, it's called an annuity due. A perpetuity is an infinite series of equal payments, so amount X for an infinite number of periods forever. The perpetuity formula is the present value is equal to the coupon divided by the interest rate. The annuity formula is a little bit more complex because it takes into account the number of periods, as we saw in our previous equation. This is a slight variation on the present value and future value equations. So here's an example. After carefully going over your budget, you've determined you can afford to pay $632 per month towards a new sports car. Call up your local bank and find out that the going rate is 1% per month for 48 months. So how much can you borrow and still meet your payments of $632 per month? So what you want to do is you want to calculate based on borrowing money today, which means the present value. If we use the formula, we see that you're able to borrow about $24,000, given that the current interest, even the interest rate at the bank, in a 48 period. So here's another example, finding the number of payments. So you ran a little shorter on your spring break vacation, so you put $1,000 on your credit card. You can only afford to make the minimum payment of $20 per month. The interest rate on the credit card is 1.5% per month. How long will you need to pay off the $1,000 if you make the minimum payment? This is rather interesting because we see when we use our equation that it would be almost 8 years. Now, if you add up the total interest that you're going to pay, you're almost going to pay twice the amount that you originally borrowed. So this is why you have to be very careful with making the minimum payments on credit cards. This is why credit card companies love you to make the minimum payments because they make tremendous amounts of interest and you basically almost never pay off the loan. Remember, this is only if you don't charge anything more on the card, which people usually do. So the answer is pay it off every month and don't turn that high of an interest rate into a loan. Here's another one, another example. Suppose you borrow $2,000 at 5%. You're going to make annual payments of $734.42. How long will it take you to pay off the loan? About 3 years using our equations. So the terms and formulas for this chapter: PV equals present value, what future cash flows are worth today. Again, future value is what cash flows are worth in the future. Interest rate, rate of return, discount rate per period. Per periods are normally 1 year, and T is number of periods, normally number of years, and C is the cash amount. The future value of C per period for T periods at R% per period. This is our future value of an annuity, and this is the second term in this is called the annuity future value factor. So we have to know how much the cash flow is, how many periods, and what percent we're going to compound the cash flow. Present value is the same thing, except that we have something called an annuity present value factor, and we have to know again what the interest rate is going to be, so we can discount the future values. And a perpetuity has the same cash flow for every year forever. It's a very simple equation. The key is recognizing these and placing the cash flows in the right time periods. Timelines are very helpful here. So what's our terminology? Present value of multiple cash flows, future value of multiple cash flows, an annuity due, a perpetuity, the effective annual rate, which we really didn't talk about, and the annual percentage rate, which we really didn't talk about. You can read about these in your text. And continuous compounding, which is another variation on the way it set. So what are the most important topics of this chapter? Multiple cash flows are moved both forward in time and into present value, just like single payments. It's the same present value and future value, compounding and discounting. The only difference is that there's a series of single payments moved either into the future or moved back into the present time. Annuities are a special case of multiple cash flows in that they are a fixed, equal, uninterrupted series of payments or receipts. This is what we see with bonds. You have a bond with a maturity rate. It pays interest maybe every 6 months or once a year, and so a bond could be considered. The effective annual rate and the annual percentage rate are two methods to determine the cost of a loan. You need to understand the difference between those in order to be a wise consumer. You can read about those in the text. And loans can be pure discount, interest only, amortized with fixed principal or fixed payments, and we normally would encounter these in our purchasing of it. So if you have any questions, please ask them in the Q&A thread. I will respond there, and we'll see you on the class shell.